Good morning to all of you. Today we'll be discussing classification of discrete time systems, and we'll be looking at its first categorization or class, that is static versus dynamic systems. So we'll see the difference in how the system can be classified as static or dynamic. In previous session we have already discussed how to obtain the block diagram representation of the given discrete time system by using its input output equation. Okay, so let's start today's session. So discussing is classification of discrete time systems. So discrete time systems can be classified according to the general properties that they satisfy. So the generalized classification of discrete time systems comprises static versus dynamic systems. Second one is time invariant versus time variant systems. Third one is linear versus non-linear systems. Fourth one is causal versus non-causal systems. And the fifth one is stable versus unstable systems. So the discrete systems can be classified into any one of these categories, that is, it may possess some of these characteristics, such as it may be static, it may be dynamic, it may be time variant or invariant, or it may be linear or non-linear, it may be causal or non-causal, it may be stable or unstable. Right? So basically these are 5 generalized classification of discrete time systems. So today we'll be discussing the first category, that is static versus dynamic system, and how to differentiate between static and dynamic system. Static versus dynamic systems. So the discrete time system is called static, or it is also referred as memoryless, if its output, that is y of n, at any instant small n depends only on the input sample at the same time, but not on past or future samples of the input. That means the output y of n should be dependent on input x of n only. Right? I'm identifying the output of the discrete time system at time instant small n, so that output should, that is y of n at time instant small n, should depend only on the input sample at the current time instant, or the same time instant, that is input at time instant small n, input x of n at time instance small n. It should not depend on past or future samples of the input. If current n instance is small n, so what will be the past input samples? So the past input sample will be x of n minus 1, x of n minus 2, x of n minus 3, and so on, right? And future input sample may be x of n plus 1, x of n plus 2, x of n plus 3, and so on. So this can be considered as what? Past input samples, right? And these are the future input sample. Okay, again this small n is some positive value or positive time instance. So likewise, again it may be small n can be positive or it can be negative again in if you are identifying or representing the x of n minus 1. So this will be again considered as the past input sample and these are the future input samples. So I can call it as what? Past inputs, right? And these are future input samples. So in case of static systems, the output y of n depends on current input sample or the present input sample. But it does not depend on past or future input sample. If it depends on past or future input sample, so in that case that system can be called as dynamic system. Right? So in case of dynamic system, output may depend on current input sample as well as it depends on past and future input sample. Right? So if the output of a system at time small n, right, at time small n is completely determined by the input sample in the interval from, just for example, if I am considering one interval, that is small n minus capital N, right, to small n. So I am determining the output of the discrete time system, that is output y of n of the discrete time system in the interval n minus capital N to small n. Here if I am considering the value of capital N greater than or equals to 0, then the system is said to have memory of duration capital N, right? Because it has to store this capital N number of samples in the memory to determine the current output y of n. Right? Just for example, as this condition specifies here, capital N is greater than or equals to 0, and if I'm taking n is equals to 0, then this uh, duration will be simply small n. Okay, so it will be small n minus 0 to small n. That means the output depends on the current input sample applied at the instant small n only, and the value of n is equals to capital N is equals to 0. So therefore the system has memory of duration 0. Okay. That means it doesn't have to store any sample because the output depends on the current input sample at the current instance of time, that is x of n. So it doesn't require any memory. But if I am taking n greater than 0, right? So in that case, if just for example, if I am taking capital N is equals to 1, so this duration will be n minus 1 to small n. If I am taking n is equals to 2, so n minus 2 to small n. So in this case, it requires single memory unit because capital N is equals to 1 here. So therefore, the memory duration will be 1. Okay, as well as it is single memory unit is required here. Right? In this case, capital N is equals to 2. So the system has a duration to memory. Right? That means it requires 2 memory units. So likewise, I can take capital N, okay, which can be any value which is greater than 0. Right? So up to N. So during this interval, it requires capital N units of memory, okay, for storing the input samples. Right? And if I am considering the here I have considered capital N as a finite value. Right? So therefore it requires some finite memory. In this case it requires only single memory unit. Here it requires 2 memory units. So it requires finite memory. Right? But if I am considering N as any infinite number, so in that case the system requires infinite memory. Right? So it is infinite memory system. Okay. So that is what the difference between static and dynamic system. So in case of static system, the output of discrete time system depends on the current or present input that has been applied to the system. In case of dynamic system, it may also depend on the past or future input samples. So let's look at one example here. So just for example, if we have provided with different systems, of n is equals to a to x of n. In examination, this type of examples may be asked, this type of problems can be asked. So first equation is y of n is equals to a into x of n. Second one is y of n is equals to small n into x of n plus b into x cube of n. Third one is, just for example, y of n is equals to x of n plus 3 x of n minus 1. Fourth one is y of n is equals to summation k is equals to 0 to small m x of n minus k. Fifth one is y of n is equals to, just for example, k is equals to 0 to infinity. Again, I will take it as x of n minus k. So these are some of the systems which are given in the problem, okay, and you have to identify whether these systems are static or dynamic. So you have to determine whether the given system is static or dynamic. So how you will identify the solution here? So if we start with the first equation, first input output equation. So here the output y of n, how output is generated when I am applying current input x of n to the discrete time system capital T. So this input is getting scaled with the constant a. Okay, so it has been getting multiplied with some constant small a. So this is the output. So if you observe this output, so this output depends only on the current input sample, okay, but it does not include any past inputs or future input sample. Okay. So therefore here you will specify as output y of n of given discrete time system depends on current, or you can say present input sample, but future or past input samples. Therefore, the given system is static. So likewise, you can identify whether the given system is static or dynamic. Similar is the case, okay, in the second input output equation. So what is the second input output equation given in the example? So here it is y of n is equals to n into x of n, right? Y of n is equals to n into x of n plus b into x cube of n. Okay, so b into x cube of n. Right? So again, in this system, what is happening? So output y of n is obtained when you are applying input x of n to the system. And how this output is generated? So input is getting multiplied with some variable, okay, that is small n, that is discrete time, right, variable, plus the input is getting cube, right? So the cube of input is identified, that is x cube of n, and then it is getting multiplied with some constant again. It is getting scaled with constant small b, and then these two terms are added. So how this output is identified? So again, if you observe the output of the system here, that is y of n at current time instance small n, so it depends on the current input sample, that is x of n. Here also the current input sample is there, x of n, only its cube has been taken, right? So again, output doesn't depend on the past or future input sample. So again, in this case, the system is static system. It is not dynamic system, right? Because output depends on the current input samples x of n, right? But just for example, if this equation, okay, is this given equation is like this, just for example, y of n is equals to, the first term is just same, that is n into x of n, right? But instead of x cube of n, if I am taking it as x of n cube, right? What has been taken here, x of n cube. So in this case, how you will identify or how you will classify this system, whether it is static or dynamic? So again, if you observe the output in the first term, the the terms comprising present inputs are available, that is, in this case, the output of system depends on current input sample. But if you observe the second term, okay, in this equation, so if I am considering the time unit small n is equals to 3, that means I am identifying the response of system at current time instance 3, right? So how the input output equation will be then? Y of 3 is equals to 3 multiplied by x of 3 plus b multiplied by x of 3 cube, right? So what does it means? 3 multiplied by x of 3 plus b into x of 27, right? So the current time instance is 3, right? So the current input sample at time instance 3 is x of 3. So this is the present input sample, okay, or the current input sample. But this is the future input sample, okay. So these are future input sample, x of 27. So therefore, this system is not static in this case, okay. So it is a dynamic system, okay, it is a dynamic system. But in the given input-output equation, we are identifying the cube of input sample itself, okay. Not we are not taking the cube of current input sample, or the cube of the discrete time. Okay, here we are taking the cube of current input sample. Therefore, the system is static as per this equation. But if you are using this equation, or if this equation is given, so in this case, the system is not static; it is a dynamic system. Okay, irrespective of value of n. Okay, it may be negative or it may be positive. Okay. So again, if you are considering the value of n is equals to -2, just for example, so the equation will be y of -2 n into, that is -2 into x of -2 plus b into x of -2 cube. So what will be that value? So it will be -8. So in this case, this will be again a present input sample, because current time unit I have taken it as -2, right? So it is present input sample, but this one is past input sample. Okay, because it is a negative value, right? So it is a past input sample, right? So again, output depends here on the present and past input sample. So therefore system is, overall the system is dynamic in this case. Okay, if this system is, given system is static. So this is how you are identifying static and dynamic system. Okay. So third one is y of n is equals to x of n. Sorry, y of n is equals to x of n plus 3x of n minus 1. Okay. So include one whiteboard here. So or here itself I will solve it. So the third equation is what? Y of n is equals to x of n plus 3x of n minus 1. So in this case again, the output, if you observe this equation, so output y of n depends on present input and past input. Okay, so therefore system is dynamic. Okay. In solution, you have to write down the statement that were written in the first system equation solution. Correct. So similar statement you can specify. Right. So here it is a dynamic system. What is the fourth equation? So fourth one is y of n is equals to summation n is equals to, sorry, k is equals to 0 to n x of n minus k. So if you observe this input output equation again, so here the value of k is 0. Okay, minimum value of k is 0. So these limits are starting from 0 to final value is n, right? So if you write down or substitute these values of k here in this equation, then this equation can be written as x of n, right, plus next value will be, next value of k will be 1. So it will be, so it will be x of, so it will be x of n minus 1 plus x of n minus 2 plus and so on. The last value will be, the last value of k is n. Okay, so it will be simply x of 0, because it will be x of n minus n. So it will be x of 0. So if you observe this equation here again, so in this case the output y of n of the system depends on, again, present input sample, that is x of n, and all these are the past input sample, that is x of n minus 1, x of n minus 2, so on. Right? So therefore again system is dynamic in this case. So it is a dynamic system. Right? So so in this case, if you observe, you have to store multiple samples. Okay, but the limit is finite in this case, because it is varying from k is equals to 0 to current inputs, current time instance, right? So therefore it requires what? Finite memory, right? So it is a dynamic system with finite dynamic system with finite memory, right? So here also in previous example, here you require only one memory element to store the previous sample. So again it is dynamic system with finite memory. Okay. Now next example, fifth one. Y of n is equals to, again summation k is equals to 0 to infinity x of n minus k. So here the limit was finite, but here the limits are infinite. Okay. So here the if I am substituting the values of k, so this equation will be, again if I am starting with the first value of k, so k is 0 here, right? So it will be x of n simply. If I am substituting k is equals to 1, so it will be x of n minus 1, then x of n minus 2, right? Plus and so on. Okay, somewhere there will be a value small n occurring, okay, between these values, right? 0 to infinity. So between these value small n will occur. Okay, so that will be x of 0. If I'm substituting k is equals to small n, so n minus n will be 0, plus, so after small n what will the next value? So it will be n plus 1, right? So it will be simply x of 1 in that case, because it will be n minus n plus 1, because I am substituting the value of k is equals to n comma n plus 1 comma n plus 2, likewise and so on, because k is varying up to infinity, so it can be any value. So it will be x of 1, then x of 2, right? Plus and so on, right? So if you again observe these input output equations, so in this case the output depends on present input, past inputs, or maybe this can be your future input samples, right? System's future input sample. If I'm taking n is equals to, just for example, minus 1, right? So these values, the output equation, input output equation will be y of minus 1 is equals to x of minus 1, right? And here it will be x of minus 2, x of minus 3, and so on. So these values will be simply x of 0, x of 1, x of 2 will be occurring in that equation. So in that case the output depends on the present input, past inputs, and maybe future input sample. So again this system is dynamic, okay, it is not a static system, right? But in this case the memory is infinite. Okay, so it is dynamic system with infinite memory. So this is how you can identify whether the given systems are static or dynamic. So the systems can be classified into these 5 categories, right, or classes. System can be static, or it can be time invariant, it can be dynamic or time variant, linear or non-linear, causal, non-causal, stable or unstable. So we've seen one example here also, how systems can be classified or identified whether these systems are static or dynamic system. So in case of static system, the output of system, that is y of n, depends only on the present input sample, that is x of n. It doesn't depend on the past or future input sample, that is x of n minus 1 or x of n minus 2, x of n minus 3, and so on, or future input sample x of n plus 1, x of n plus 2 plus, or x of n plus 3, and so on. Okay. So it depends on the present input sample in case of static system, otherwise the system is dynamic. as in how to identify the static and dynamic system. So in next session we'll be discussing next category, that is time invariant versus time variant system. Okay. So thank you for joining this session.